Hi, Dr. Ward here, and we are going to take a look at some of the fundamental mathematical concepts behind dimensional analysis before we get into the dimensional analysis problems themselves. Most of what we're going to cover in this video should be review, and you may feel comfortable jumping ahead to the next video where we start getting into some of the actual dimensional analysis problem solving. However, it could just be a good refresher for you, and sometimes it does help to really get a feel for what's behind the methods that we'll be using in these later videos, especially as they get more and more complex. So let's get started. First of all, what is 4 times 1? It's 4. What about 3.1415 times 1? Well, that's 3.1415. How about 6.02 times 10 to the 23rd power times 1 equals, even if you're not familiar with the scientific notation, you probably could work out that this would be 6.02 times 10 to the 23rd. All of this is based on the concept that any value multiplied times 1 equals itself. So that's the first thing we need to keep in mind when we're doing dimensional analysis. The second concept is something like this. What is 4 over 4? It equals 1. How about 3.1415 over 3.1415 equals 1. And 6.02 times 10 to the 23rd over 6.02 times 10 to the 23rd equals 1. This is our second foundational concept here. Any ratio or fraction that has the same value on the top and the bottom equals 1. Now what happens if we put these two concepts together? We might get a problem like 8.4 times 3.1415 over 3.1415. It equals 8.4. So, combining these two ideas, we can say that any number multiplied times a ratio with equal values on the top and the bottom equals itself, since that ratio is equal to 1. This is absolutely the defining factor of dimensional analysis. We can multiply any value times a ratio with equal values on the top and bottom, and the value equals itself. So let's take a look at two more quick things that we need to understand in order to really get a handle on dimensional analysis. All right, let's take a look at a ratio like 6x over 3x. Now, hopefully we understand that if we have the x on the top and the bottom, we can actually cancel those out and we end up with 6 over 3, which of course would equal 2 if we wanted to simplify it. But the underlying factor here that we want to talk about is the fact that anytime you have the same unit or variable on the top and bottom of a ratio, it cancels out. We're going to apply that to dimensional analysis. The other thing that I want to talk about is if we have something like $1 equals 4 quarters. Okay, so I think we can all agree on that. Which means if we divide both sides by 4 quarters, we have $1 over 4 quarters equals 4 quarters over 4 quarters. So that means that since we know that 4 quarters over 4 quarters equals 1, $1 over 4 quarters equals 1, and that's because, as we discussed earlier, any ratio with equal values on the top and the bottom equals 1. This is the same value, it's the same amount of money, but it's expressed in two different units. So we're going to take canceling out units that appear on the top and the bottom, different units of the same value on the top and the bottom, the two facts that we learned earlier about multiplying a value times 1 and ratios with the same value on top and bottom being equal to 1, all of these come together to allow us to perform dimensional analysis. So let's recap. Any number multiplied by 1 equals itself. any ratio or fraction with the same value on the top and the bottom equals 1. Multiplying any value times a ratio with equal values on the top and bottom equals itself. And any unit that appears on the top and bottom of a ratio can be canceled out. We're going to use all these facts in the next videos as we start to tackle dimensional analysis problems.